Quicker than the actual texture of spacetime itself, it has the capacity to keep up with it. Thus, it will gradually destroy this idea, filling me with a growing sense of unease. At present, the night sky above is undergoing rapid change, and in the next few decades, perhaps even sooner, it could become almost unrecognizable. Leading experts, including Neil deGrasse Tyson, have sounded the alarm, recognizing the inevitable changes brought about by the shifting position of Polaris. The changes behind this phenomenon are surprisingly unexpected. Polaris, commonly known as the North Star, has been a reliable fixture in the sky for centuries, serving as a crucial reference point for astronomers, pilots, and stargazers alike. However, this could soon change, altering the way we perceive the sky and how we navigate the universe. We should delve into the implications of this transformation. For centuries, Polaris has been a guiding beacon for sailors and astronomers, remaining steadfast in the sky. This consistency has been essential for navigation, yet this stability may soon be disrupted. A paper released by the prestigious Royal Astronomical Society in September 2023 raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one where it may explode and disappear from view permanently, radically altering the sky as we know it. Before considering the potential consequences of this event, we must explore the characteristics of the star itself. Polaris stands out due to its position near the celestial North Pole. Located directly above Earth's northernmost point, it appears almost unmoving in the sky. It is part of the Ursa Minor constellation, often referred to as the Little Dipper. Polaris emits a moderate degree of brightness and is classified as a yellow-white supergiant star. It is significantly larger and brighter than our Sun. However, Polaris is not just a single star. It is part of a complex triple star system composed of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational interactions between these stars influence their orbits and behaviors, and any disturbances in these interactions could cause shifts in their brightness or pulsation patterns. Despite this, the exact nature of these forces is not yet fully understood. Polaris is located approximately 323 light-years from Earth, meaning that the light we observe today began its journey centuries ago. If Polaris were to explode, the effects would not be visible to us for over 300 years. It is even possible that Polaris has already exploded, but we have yet to witness the consequences. Throughout history, the North Star has held significant cultural, navigational, and symbolic importance. Its unwavering position in the sky has made it an invaluable guide for ancient sailors navigating vast seas and lands. Symbolically, Polaris has represented constancy and direction, remaining unchanged in an ever-shifting sky. For astronomers, Polaris has served as a crucial reference point in the study of celestial movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided key insights into the properties of stars and the behavior of variable stars. This characteristic has also been essential in measuring cosmic distances and calibrating scientific instruments. Since its pulsations follow a predictable pattern, its behavior has historically been relatively easy to forecast. However, in recent years, Polaris has begun to show signs of deviating from its usual behavior. This anomaly in its pulsation cycle has caught the attention of astronomers, prompting further investigation into the cause of these unexpected changes. Instead of following its typical rhythm, Polaris has started to exhibit erratic dimming, raising concerns that the star may be nearing the end of its life cycle. This behavior aligns with patterns observed in stars that are approaching their final stages. The continuous increase in Polaris' pulsation period, which was once stable, has been traced back to interactions within its star system. Over the past year, there has been an annual increase of approximately 4.5 seconds in the pulsation period. While this may seem like a minor change, it has significant implications. Some astronomers suggest that the gravitational forces between the stars in the Polaris system could be driving these changes, directly affecting its atmospheric conditions and pulsation patterns. Others worry that Polaris is entering a critical phase that could lead to an explosion. The similarities between Polaris behavior and that of Betelgeuse, a prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, raising concerns that they may be approaching a catastrophic explosion. Stars nearing the end of their life cycles often display such irregularities before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star approaches the end of its life, it undergoes several stages, including the red giant phase, eventually culminating in a supernova explosion. Given the unusual pulsations observed in Polaris, scientists predict that it has entered the phase of helium depletion, which is common for supergiant stars nearing the end of their lifespan. These anomalies align with patterns seen in other stars in their final stages. However, strong evidence of an imminent supernova remains uncertain, and astronomers continue to monitor these irregularities to better understand the fate of Polaris. If Polaris were to undergo a supernova explosion, it would be an extraordinary event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brightness could dramatically alter our view of key celestial bodies, such as the Big Dipper or Ursa Major, in which Polaris plays a critical role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes due to its immense distance from us. It probably won't be as outwardly staggering as the scarab juice, but it may still be visible to the unaided eye for a lengthy period, outshining nearby stars. This would undoubtedly draw the attention of astronomers and observatories, generating widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or climate would be less significant compared to a supernova closer to our planet. Now, let's turn our focus to what will happen to Polaris itself. What is its future after a potential supernova explosion? It's crucial to understand that, although massive stars generally end their lives in a supernova, this is unlikely for Polaris. When a massive star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to disintegrate. However, Polaris isn't massive enough to experience such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition won't result in a supernova. Rather, it will mark a quieter end as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium-mass star that has depleted its nuclear fuel. Despite its small size, roughly that of Earth, it will still contain the mass of the Sun. Once this transformation occurs, we will no longer see Polaris as we do today. By comparing the potential explosion of Polaris to actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate fates. For example, supernovae such as SN 1987A, SN 2011FA, and SN 2014J have provided crucial data that help us understand what might happen to Polaris in the future. SN 1054, for instance, led to the formation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, offering astronomers a rich field of study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided fundamental insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries help us understand the unique characteristics of Polaris. The formation of nebulae like the Crab Nebula occurs when material ejected during a supernova interacts with surrounding interstellar gas and dust. This process enriches the gas with heavier elements, contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the composition and velocity of ejected material between a potential Polaris explosion and other observed supernova events. By analyzing light curves, spectra, and remnants from these events, they can make predictions about the possible explosion of Polaris. This research will help determine whether Polaris explosion could lead to nebula formation or impact stellar distributions in significant ways. Another critical area of study involves the pulsational variability of stars nearing the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. Variations in pulsations in stars approaching the end of their lives may indicate internal instability or an impending catastrophic event, providing valuable clues about the processes leading to supernovae. Despite detailed observations and ongoing research, space experts remain puzzled by the anomalies in Polaris behavior. Understanding the causes behind these irregularities is crucial for advancing our knowledge of stellar evolution. Investigating the factors responsible for Polaris erratic pulsations requires collaboration across multiple scientific disciplines, along with the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would require recalibration, affecting the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural traditions that rely on celestial markers, emphasizing the significance of such an event. The mysterious behavior of Polaris highlights the urgent need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The disappearance of Polaris would have significant implications for various fields of study and cultural practices. One of the major consequences would be the need to recalibrate astronomical tools and methods. Since Polaris has long been a reliable reference point for measuring distances in the universe, its disappearance would disrupt current cosmological models. Astronomers have relied on the predictable behavior of the star for centuries to help map the universe. Without it, alternative measurement methods would need to be developed, which could take years of study and adjustment. Additionally, Polaris has always played a crucial role in navigation, particularly for sailors and explorers. Its fixed position in the sky has guided travelers across vast oceans and unfamiliar lands. If Polaris were to vanish, its disappearance would pose challenges for modern navigation systems that still depend on celestial bodies for guidance. This could be particularly problematic in remote areas where electronic navigation aids may not be as effective or accessible. Beyond practical concerns, the cultural significance of Polaris cannot be overlooked. For many ancient civilizations, the North Star symbolized stability and direction, offering a sense of constancy in an otherwise chaotic world. Its disappearance would likely have an impact on various communities, especially those that have long associated the star with guidance and hope. Even today, many cultures continue to see Polaris as a symbol of permanence and resilience despite life's uncertainties. The potential fading of Polaris also underscores the dynamic and ever-changing nature of the universe. Stars like Polaris undergo various stages throughout their lifetimes, and their eventual demise is simply part of the natural cosmic cycle. While the idea of losing such a prominent and dependable star may seem unsettling, it also serves as a reminder of the vast and complex processes occurring in the universe beyond our comprehension. Just as new stars are born and old ones die, the sky above us is constantly shifting and evolving. As we continue to study the stars and their behavior, the changes in Polaris pulsation patterns will likely provide astronomers with even more information about the life cycle of stars and the forces that govern their existence. This knowledge could ultimately help scientists understand the broader processes behind the formation, evolution, and death of stars. By investigating how stars like Polaris behave as they near the end of their lives, we can gain insights into the mysteries of stellar evolution and the ways in which the universe itself is constantly changing. Despite the uncertainty surrounding the fate of Polaris, one thing is clear. It has been an invaluable resource for astronomers, navigators, and cultural traditions for centuries. Whether it ultimately transforms into a white dwarf or undergoes some other unexpected phase, its eventual disappearance will undoubtedly mark the end of an important era in our understanding of the universe. However, as we've seen with other celestial events, new stars and new discoveries will continue to emerge, offering humanity fresh insights into the nature of the cosmos. While the changes occurring with Polaris may be unsettling, they also provide a unique opportunity for scientists and researchers to explore the fundamental principles of stellar life cycles and the cosmic forces that shape them. The future of Polaris remains uncertain, but the journey to uncover its ultimate fate is an exciting one, offering potential breakthroughs in our understanding of the universe and the forces that govern it.